What if I told you one of the largest botnets in history, or at least one of the most well known and most damaging botnets in history, was made by a couple of teenagers who were trying to DDoS Minecraft servers? Now, if you've been around the information security space for a long time, you already know the story about Mirai. Mirai is like the biggest name in botnet history. But I do think that there are a couple of things that we can extract from the Mirai story to kind of highlight things that we can learn from the story. Now, I have got a blog page set up that is not monetized in any way. It is about decentralized malware. I'll leave a link to it down in the description. There's no monetization on it. I'm not trying to sell you anything. It's just basically where I'm collecting a lot of my research on decentralized botnets, decentralized malware, on Mirai, different things like that. So this has two different links. One to the Usenix talk that was given in 2017. It's a really good breakdown on how they tracked Mirai, how it was clustered, because, spoiler alert, eventually the source code gets leaked intentionally, and there are 1,000 different clusters that all do things in different ways. And it also talks about Mirai's DDoS methodologies, because one of the primary ways that Mirai, the botnet, was monetized was basically to do DDoS as a service. So let's kind of dive into what Mirai is. Now, Mirai is a botnet. The way a typical piece of malware will work is you have a C2. So C2 and all of your different infected hosts down here will reach out to that C2. So you've got infected hosts all over the place, and they are all reaching out to this C2. Now, the thing about this approach is if this C2 disappears, now all of a sudden, those bots are all trying to reach out to a server that does not exist. And there are various different ways that you can kind of get around this, okay? And I'm not trying to basically say that botnetting is the only way to do it. You can create more C2s and have all of these different bots know basically where these C2s are and how to reach out to them, and have some kind of algorithm wherein if one C2 goes down, then it doesn't all just crumble. That has been the approach of most malware, and will continue being the approach of most malware because it's the simplest way to do things. The thing about it, though, is this will always be vulnerable to C2 takedowns. And that's just kind of become a fact of life for malware developers, for the vast majority of malware developers at least. There will always be a C2 that gets taken down, and you will have to kind of restand up infrastructure, restart all over again. No big deal. That's just kind of the life of a malware operator. What botnets do instead is they still have C2s. A lot of people think that botnets have zero C2s. Sometimes, actually, I'll go ahead and keep multiple C2s in. Sometimes they have multiple C2s. The difference is there is a mechanism wherein these bots can also talk to each other. So these bots can now speak to each other. And these bots can do things like pushing updates to each other. They can spread messages to each other. And if you have got a node or an infected machine that is behind a firewall that is not able to communicate directly to the C2, but it can directly communicate to other bots who can directly communicate to the C2, then that allows the messaging to be passed around. So if we've got this, infected node right here, and for whatever reason it can't communicate to these C2s, it can communicate to this bot though, and this bot can also communicate to the C2s. So that's one of the things about botnets that make them especially attractive, but they're also incredibly complex to code. It is very, very difficult to code in a mechanism by which all of these bots can talk to each other, also talk to C2s, update each other, all of that. It also creates a unique class of security vulnerabilities within the botnets themselves, wherein now an individual bot within the network can also listen in to all of the messages being passed to other bots if you design it badly. So it's a very unique and dynamic environment that you've got here. And this is kind of how Mirai spread so quickly. It also spread in a worm-like fashion. I put up a short a while ago about worms. Worms are pieces of malware that can spread on their own. So each individual bot here is going to search out and look for infected machines that are not, and look for not infected machines, they're going to look for other machines that are vulnerable. If I can click this arrow, there we go. They are vulnerable to whatever, mechanism that it's using to spread. Mirai used a lot of, non-zero day, but popular vulnerabilities that are wormable. So these are vulnerabilities that are fairly trivial to execute or to exploit, and it could spread fairly easily using a lot of these exploits. So a lot of times it's low hanging fruit, but if you're doing things like, DDoS for service, or if you're doing things like installing miners, that's perfectly fine. You don't really care that it's, an enterprise, piece of, hardware or anything like that. You just need something that you can pop a miner on. And one might argue that you would kind of tend to want those, lower quality targets because they're less likely to have AV and EDR installed on them, and they're less likely to notice that their CPU or GPU spins up whenever the miner is installed. And they're less likely to notice when they're being used in a DDoS attack. So these individual nodes are going to then scan the internet, look for other vulnerable PCs, and spread and spread and spread. Mirai spread to hundreds of thousands of victims over time, especially if you consider all of the different variants. So what kind of happened was these kids got caught. They developed this malware. It spread really, really far, and they started using it for extortion, DDoS, for hire, different things like that. And when these kids got caught, and when I say kids, they were literally teenagers who were in college. One of the ways they actually got caught was one of the kids who, first started developing it, used it to DDoS their school because they didn't get class placement that they wanted. So they kind of got caught because they immediately took it in a personal direction, which was really stupid, obviously. But, they were using it for DDoS, mostly against Minecraft servers and, different gaming targets, things like that. When they were starting to get caught, they dumped the source code online, which created a ton of different variants, to include the Satori botnet. The Satori botnet was used primarily, I believe, for mining. So it was using, basically mining software to kind of, mine cryptocurrency, and that was kind of its method of monetization. One of the interesting things, though, is there is a variant of Satori that spread specifically via vulnerabilities in mining software that was left exposed to the internet, and it would install itself on the miners, and it would basically just change the wallet address that these miners were mining for. So you wouldn't actually be able to notice that anything malicious happened unless you went to go look at your mining progress, essentially, and notice that, all of your money is, no longer increasing. So you're no longer actually mining for your own wallet, you're mining for somebody else's wallet. So that to me was really cool. It's a really clever way of monetizing, infrastructure that is already doing the mining. So nobody's going to really notice if, it spins up the GPU or CPU because that's what it's supposed to do. So I kind of thought that was an interesting, mode of monetization. I've got some more resources here about Satori. I'll kind of, I'll obviously link my blog down in the description. Again, I'm not monetizing this in any way. It's just kind of a way for me to, collect all of my research. Also, this is from ChatGPT, so most of it's probably right. That's about it. I really just kind of wanted to highlight Mirai because it's interesting and a lot of people talk about it. But it also has some really interesting things about the way that it's laid out. Obviously, botnets and, peer-to-peer communication in general is interesting. But, Mirai itself has been around for almost a decade now. So it's just kind of an interesting story to begin with. That's about it. Take it easy. Peace.